an even number? Every even number? Can you write every even number for me right now? Can anyone write every even number that exists? 2n, kick ass. So how do I write every odd number that exists? 2n minus 1. So if you do, can somebody give me a different, so this might be a specific odd number, give me a different odd number. Sure, but it's still related to this one. So like 2w minus 1, that's also an odd number, right? So if I just said the sum of an even and an odd number is odd, that's easy. Because here's an even number, here's an odd number, and if I factor a 2 out, that is twice something minus 1, that's odd. We did that before. The trick with this problem is, this doesn't just say add 2 odd numbers together. We could do that with these two. It says the sum of an even number, any even number of odd numbers. Is anybody at all with me? So the first step in a claim like this is just pick a few examples and see if it even holds water to any degree. Yes? The second step is to try to represent, since you're talking about an infinite number of things, let's just represent them so I can write them. I don't know if you guys are with me at all. So I could add those two together. Can you guys take a minute and add these two odd numbers together? Add those two odd numbers together. That is an even number of odd numbers, correct? Add those together. So you all agree with me that those are two different odd numbers, potentially? They could be the same, but more than likely they're different. But they're both odd. Is everybody cool with that? Okay. Remember that one short as word, 2n minus 1. So twice something minus 1 is an odd number. It just is. So what do you get when you add those together? There's not a lot you can do with it, right? Some of you guys might have been overthinking it, but there really isn't that much you can do. The only like terms I have is, what are the only like terms I have? Yeah, minus 1 is minus 2. And what do all of these have? 2. So I can take a 2 out, can't I? And what's left? M plus W minus 1. Kick ass, yes? Just cut everybody in half, yes? If you take a 2 out, that's opposite of distributing, which is multiplication. When I take something out, it's division. That says that the answer to 2 odd numbers added is double some counting number. You guys with me? And of course, what is double a counting number? What kind of number is that? If I double a counting number, what kind of number do I get, odd or even? Even, by definition, right? Even numbers, by definition, have a factor of 2. So if I double any counting number in the universe, I'm going to get a freaking even. No, so agree with me. So can anyone tell me what the hell I just did? What did we together just discover? What did I start with? What are these? These are each what? Yeah, so I've got 2 odd numbers, yes? That's an even number of odd numbers, and when we added them, we got what kind of number? Even number. Now, why does that not prove their claim? What was the claim made in number 4? Did it say the sum of 2 odd numbers? No, it said the sum of an even number. So for this to be true, we'd have to prove it for 4, 6, 8, 10, 12, 18 million. says that you guys are not with me. I'll be okay. I'll get over it. You have to let go. I wouldn't give you this kind of problem out of nowhere on the test. Would we? But can you just inhabit this idea for a moment, right? Is everybody really cool with 2n is an even number and 2n is an odd? I can use that to prove things about odd and even numbers, because if I want to prove this, individual examples don't prove shit. But if I do what they want me to do with every odd number, that'll prove something. So what we have proven so far is if I have 2 odd numbers, they add to be an even number. You all agree that is a good next point of evidence. This is pretty good evidence, right? Now let me ask you guys, if I was going to add 4 odd numbers, how could I use what we just figured out to make that next step? Every 2 odd numbers, what did we just prove? Every 2 odd numbers adds to even number. What's the sum of 2 even numbers? If I take an even number plus an even number, what kind of number do I get? Why? Because it comes out to be twice some counting number, yes? N plus m is some other counting number. If m is 1 and m is 2, then that's 3. And that's twice 3, which is 6. You guys follow. If I have a number, then I can factor 2 out of everything, that's even. By definition, that's even. Does that make sense? And if I have a number that when I factor 2 out, it's left with a minus 1 at the end or something, that's like this one. Well, not this one. If I have something in this form, that would be odd. If I have something in this form, that would be even. That's in the even form, so is this. Okay. I'm just going to tell you, because so if we prove that any 2 odd numbers adds to an even, that's what we proved. And we just proved that the sum of any 2 even numbers is even. Yes? If I had like 8 odd numbers to add, 8 odd numbers, can't I group those into 2, 2, 2 odds? Jeff, you're thinking multiplication. 2, 2, 2, 2. Right, 2, 4, 6, 8, yes? And every 2 odd numbers, what did we prove they do? Every 2 odd numbers, when you add them, you get an even number, yes? So isn't this even? That's 1 even number. That's plus 1 even number, plus 1 even number, plus 1 even number. Yes? And what do I get when I add 2 even numbers? Even numbers. So this is even plus even, which is even. And so, okay, it's not as simple as, yes, I can use a variable and that's it. So the answer to this question is you can't just use a variable, but you can build from starting with using a variable. Okay. You're all like, that's a great way to start the class, man. Feel great. I just want to show you the power, because a lot of times you guys think algebra and you have no idea why you just took what you did. But and some of you guys are sitting there like, why the shit would I ever want to know this? Well, because you never know what we discover in mathematics 30 years later, it helps solve a problem. That has happened. When they were playing with it like that's neat, and 30 years later, holy shit, we need that so we can solve this thing. All right, great. We're not going to blow it. Yeah? Okay. All right. I'm sorry. I'll stop. I just want to do that one, because it was using a variable that we hadn't done on that sheet from last time. This sheet here. We did the first 3 last time. We just didn't get to this one. So, the main focus of today is like, all right, the only rule for today is you can ask about anything that could be on this practice. On the test. So the practice test basically covers the ideas. It doesn't cover every kind of problem you might see, because otherwise it would be this big. But it does cover the ideas you're going to see, yes. You need one? Yeah. Anybody else need one? Everybody else is good? Anybody else need a practice test? Okay. Have you guys ever heard the rule of 3 that I just used? I do this when I'm doing quizzes too. I'll ask 3 times. Did I get all the quizzes? Does anybody else still have that quiz? I'll try to say it to voice. If you say it 3 times, about 95% of everybody's heard you. So as a teacher with little ones, you probably end up saying things 4 times. Assuming that one kid in the corner is like, what's going on? Okay. So today's wide open. You can ask questions from the quiz. You can ask questions from homework. You guys, none of you have ever had me for class before, is that right? Remember? So you're like, have you had me in class before? No.
I think it with the other professor.
I understand.
I'm sure if you shared it with
Okay.
your office.
My point is, this is our first time doing a review day. Yes? It's wide open. If nobody else is asking a question, it's your floor. You can ask whatever that. If you had a problem with one of the practice problems, great. If you're like, I couldn't do the practice test, Jeff, because I'm trying to do all your damn homework. Okay, do you have a question from the homework that's really giving you trouble? Ask that. If you're like, I think I'm okay, but can you do a problem like this? And then I'll make that shit up. And we'll do it. I guess follow? So on review days, I bring very little. If everybody's really freaking quiet, just staring at me, I might ask myself some questions. Hey Jeff, yeah Jeff, how do you do this? Why is this? Just because I kind of know what people have trouble with. Yes? But it's up to you guys. Whatever you want, you can ask. Which is one reason why I gave you guys this practice test. To kind of give you some specific things to focus on. So are there any questions from the quiz, from homework? This could be a very short day, or we're just gonna stand here. Yes?
So, that first section, could you go over like the minus part of it?
Oh yeah. Okay. There's 2 different problems on here that deal with minus in different ways. So one of them is obviously this one. And the other one is here, dealing with it visually, yeah? Okay. So can somebody tell me what that symbol that we still do call minus, but what does it mean in set when we're talking about sets? Yes? Yeah, so I want to take the first set, in this case not B, the set of everything that's not B. From it, I want to take away everything that is. What do I want to take away from this set? Everything that is in what? A. There you go. So I want to start with the first set. Anything that's in A that is in it, I want to take that out. Does that make sense? So it's not like subtraction can come out negative and so forth, but when I'm doing set subtraction, if there's more stuff in this set, that doesn't matter. So let me show you a really silly little quick example. Let's say I had a set C is 1, 4, 7, and set D is 4, 7, 9, 12, 15, A, B, C, smiley face. So then what is C minus D? What is C? I am subtracting shit from that. Can my answer be bigger than that? Because, so the mistake people make is you focus too much on what subtraction means with numbers. If I say 2 minus 5, you're negative 3, and you're like, I wish that's not how it worked in the real world. If I had $2 and I owe you 5, just take 2 and be happy. But unfortunately, I'm still in debt. You with me? So you guys see this as, I gotta subtract all that D shit from C. No. With sets, it literally just means start with C, take away everything from it that is also in D. That's what it means. So what's in C that is also in D? 4, 7. So what's C minus D? 1, done. Okay, right? So that is a little different from subtraction of numbers. And why is it? Because numbers are numbers and sets are sets. They're going to act differently. Maybe? No? Screen, Jeff? that okay? I don't want to play poker with any of you guys. You would just take all of them. When I play poker, it's all there. I couldn't wear glasses big enough to cover. I get like, so no bluffing. I can't do that shit. You guys, you're like, I'm not gonna give them anything. I'm not gonna let them know. Yes. Okay, so let's look back. So everybody's cool with this example? All right, so what you do when I ask you a subtraction question, you start with this set. Do we even know what that set is at the beginning? If I give you, I'm going to give you this. I'm going to give you a boo, right? A-B-U. I could call them C, or whatever that. If I have a question about not B or not A or whatever the shit, write that down. That is showing me work and it's helping yourself out. Don't try to have all that shit in your head. So let me write down what not B is. What is not B? What is B not B? What is B not B? How do I do that? What could be in B that isn't in B, considering this guy? What does this guy tell me? Everything that could have been. So what is not in B that could have been in B? 0, 1, 20. I think that's it, right? Yes. Is everybody with me on that? That is how you do not set. You look at the set, you look at what it could have been in the set, which is why I have to give you a universe to live within. Otherwise, it's going to take you forever to write the answer. Is everybody cool with that? Not B is 0, 1, 20. So you start with that set. I'm subtracting, so that is the biggest my answer could be. If I subtracted the empty set, that would be my answer, yes. Anything else, it's going to make it smaller. So how do I say this? I'm going to start with not B, and I'm going to take away everything that is also in A. So what is in not B that is also in A? Yeah, 1 and 20. So what's the answer? 0. Done. Okay, yeah. Do you guys see how I just did that? Do it just like that if you want to. Or if you hate that, don't do it that way. Do it some other way. I don't care. Yes?
Could you put another problem like that?
Okay. Okay. You want me to make one up out of nowhere, or you want me to use these things? Okay, here. Let's come back here. So say the W set is -4, 9, 11, 17, and the M set is 9, 17, 20, 25, 36, and then I want to know what, let me just do this. I want to know what M minus W is. Sorry? Yeah, you're good.
I'm just writing everything down.
So I'm going to ask you a question that you never have to answer, you never have to think about. But if you understand the answer to it, you understand this kind of problem. What is the biggest my answer could be? M minus something. What's the biggest, the largest number of things that I could have in my answer? The largest amount of stuff that could be in my answer. What set am I taking stuff away from?
M.
M. How big is M?
36.
No, I'm sorry. How many elements are in M? 5. So what's the biggest the answer to M minus W could be? 5. You with me? If you find yourself writing something larger than what the first set started off to be, that doesn't make any sense. I'm taking shit away from it. It should at most stay the same. So do you have to understand what I just said to be able to do this problem? No. Will you catch a mistake you make easier if you do understand what I just said? Yes. Okay. So what am I going to take away from M?
Can you put is that the same thing as like the line being over M?
Oh, no. So I just want to do a minus problem first.
Okay.
Just to make sure everybody's get the idea of minus. And then I'll bring not into it.
Okay.
Yeah. And that's what we call scaffolding. When a teacher sort of like, just go with me for a second. Has anybody ever watched the show Mythbusters? You ever heard of the show Mythbusters? It's really good shit. Really good shit. They kind of take a myth and they bust it by setting up an experiment to see if it works or not. And in that show, they do something called controlling the variables. I forgot where I was going with that, but it's okay. Just watch that show. So what I'm doing, there's the connection. I'm trying to just see where the misunderstanding is. So I'm going to isolate subtraction and see if that's where I'm losing people. And then I'm going to bring the not into it and see if that's where I'm losing people. So let me see. What am I taking away from M? Start with this. What am I taking away?
9.
Good. Everything that's in W also. So the 9, 17. So what's the answer? 20, 25, 36. Kick ass, yes? Okay. So let's do a quick example that, I'm sorry, did everybody get that? You can literally just do that. That will make certain, the most common mistake I would see is somebody would say 20, 25, 36, negative, or 4, negative 11, no, yeah. Right, they subtract, don't even think about that too much, but I see that mistake. If you just start with them and cross through the shit you're taking out, you're not going to introduce new stuff that shouldn't be there. So let me give this in a slightly different way. Let's say F is A, W, G, L. And what you got, Jeff? There's so many letters. Just pick one of them. All right, P is B, C, L, D, and the universe is A, B, C, D, L, G, W, O, M. Okay, I'm sorry, let me get all that there.
Is that an E?
Which one?
E?
Sorry?
The P one? The B?
P?
and then
B?
Is that E?
L?
That's an L?
Yeah, that would be an overachieving E. Yeah. El Grande, yes.
Can I see the last question? The last example?
Yeah. Sure. All right, so what is F minus not P? What is the first thing I should do for myself? Do we know what F is?
Yes.
It's staring us in the face. Yes. To be nice to ourselves, we realize we don't have not P staring me in the face. Could I, in my head, see what not P is? Do I want to keep that in there while I try to do shit to what I just thought? No. Write the damn thing down for yourself. I always have people that are like doing it in your head and then they make a little, like, just write it down. There's no problem with that. So what is not P? Put it up here. What is not P? Don't worry about F. Don't even look at F. What's not in P that could have been in P? A? D? I'm sorry, D's in there. Sorry, I'm looking at them. Yeah, BCLD is in there. So A, G, what else? Yeah, W, O, M. Okay. Is that cool? So that is everything that's not in P that could have been in P. So now I can look at these two, right? Start with F and take away what? Start with F and take away. So here's the question, right? Start with F and take away what? Everything that is in not P, yes? So start with F. Okay, what's in not P that's in here? Take that away. Take that away. Take it away. What am I left with?
L.
L. That's the answer. So if I didn't give you the set, create it. So I didn't give you not P, create it. F minus that. Okay, start with F, and then just cross through everything that's in not P, and then the answer is whatever's left. I am subtracting from F those elements that are also in the not P. Does that make any more sense?
Yeah, that makes a lot of sense.
Thank God. It's my absolute favorite phrase. Now listen, by the way. I mean, how much of you guys work with this stuff? Have you ever done much of this work outside of this class that you can remember? No. You did some of this, to be honest, when you were younger, but you probably didn't even necessarily look exactly like this, but you did stuff like this. But ain't no way, I don't remember doing shit when I was a little kid, are you kidding me? So on one level, give yourself some grace if it's not making as much sense as you want it to. But this is what you gotta do. You have to identify what are the parts I don't get so I can ask a good question. Because I can't guess as to what's in the way. How's everybody else doing? Okay. If it did make sense, did it just make it not make sense? That's the worst. I've had that happen where somebody's like, I thought I had it, now you said that. I'm like, shit. Why did I have to say that? Okay. All right. Do you want to look at the other minus one since we're talking about minus?
No, can you do like the one that says not A and B?
Real quick. Does anyone else want to see the other minus one? If I can find where I put my. There. This one down here. Just to fully get rid of the subtraction. Okay. Somebody shook their head yes. So what am I going to start with? Not A. Can somebody tell me what not A is? Tell me the numbers that would represent not A. 4, 7, 3, and 8. It's just all the numbers that are regions that are not in A. So what is in A? 1, 2, 5, 6. So what's not in A, every other freaking thing you see. Yes? That's one way to do that. It's just what is in there, and then everything else you see is not in there. Bam. So I'm talking about 3, 7, 4, 8, yes? What do I want to subtract from these regions? I want to subtract everything that is in B. So I have 3, 7, 4, 8. Which regions out of those are in B? Take these out, what am I left with? 4 and 8, done. Visually, it's even better. Because you can literally see visually what the hell is in the circle and what's not in the circle, blah, blah, blah. Yes? Is that still okay?
Wait, go back.
Yes. All right, so watch. Let me circle this shit. Not A. What's not in A? Which red letters are not in circle A?
4, 7, 3,
Yeah.
are not in A.
These 4, right?
Yeah.
From those, take away everything that's in B, of course, right? That's what that means? So out of those that I circled, which ones are in B?
7 and 3.
Take those away, what are you left with?
4 and 8.
4 and 8, done. Same idea, but a different delivery, like a different way to look at it. Okay, I'm sorry, so you wanted to talk about...
Wait, but,
So, go ahead.
I'm sorry. Why did you take away from B for taking away from A? I'm so confused.
Okay,
Does that make sense?
What is this telling me? It's telling me take not A, and that's what the ones we circled, right?
Yeah.
Okay, and it said take B away from that. Take anything that's in B away from that. That's what that says. Start with not A, so we figured out what not A was, and take away anything that is in B. So we have, this is not A, these 4 things, and we took away the things that are in B.
Okay.
Yeah. Kind of like if I said, does anyone drive a red car? You drive a red car? And anybody else? Okay, neat. Does anyone drive a blue car? Blue car? Holy shit, okay, anyone drive you drive a blue car. All right, I need a big white car. What kind of color car do you guys drive? Okay, you guys drive white cars, is that right? Okay. So if I said, no, this is gonna work. Can you guys raise your hand again? My white car drivers? Okay. What's not white car drivers then? Everybody didn't have the hand raised, correct? And I want to take away from that, take away from not white, I want to take away people that are wearing glasses.
What? How? What? Why did you get glasses and clothes from?
Just another example. I'm sorry. All right. Okay. So, real quick. Let me see. All right. If I have this group here, let me see. Oh, good. Everybody on this side of the room, right? You with me? Brand new example. Everybody on this side of the room is in one set. Are you with me? I want to subtract from this set everyone who's wearing glasses. Exactly right. Aren't you wearing glasses?
Yeah, but I'm not.
Why didn't I do shit with you? Because you're not in the set to begin with, right? So that wouldn't make any sense. So when I subtract stuff with sets, even though more things are in B, aren't 2 and 6 in B? But they don't show up here because I started with not A. And what was not A? These things. From that, what do I take away? Let's say B is the people wearing glasses. I'm going to take these people out of that group. And who's left in the group? 4 and 8. Yeah.
I'm gonna get it now.
Okay.
I got a problem.
I appreciate that, because you look at the problem like, where's this jackass getting that with glasses and shit? It's not, what's he talking about? Did he take his meds? Maybe. I can't remember. Alright, how are you doing? Is that better? Okay. Alright, again, no poker with you guys. Where are we gonna go next? Or does everything else make sense? So already, you gonna take the test of the set? I can give it to you right now. No, what you got? You good? Yeah.
The true and false one. The true and false one, like the second one, and then the one that has.
Where's it at? Sorry.
1B.
The beginning.
Oh, here, yeah. This is like trying to read a legal document. Subsection 1 of paragraph B. Okay. True or false? Which one? All of them? What does that symbol there mean? Similar, which means what more technically? They have the same size. They're the same amount of elements, right? They don't have to have the same elements, but if they do, they're automatically also similar. They also equal each other. So are B and A similar? Meaning, do they have? Okay, there's my seventh puberty. Do they have the same number of elements?
Yeah, is this true?
So it's true. So you have to understand what the symbol means. Directly, that symbol means similar, but that don't tell you shit. That means, do they have the same number of elements? All right. Can somebody tell me immediately why you don't even have to look at A and B for number 2? You don't. You can just tell me right from looking at this. What does this symbol mean?
It's talking about a set, like subset.
It's a subset of. Is 9 a set? So could not. Is everybody with me? I need you with me. How do you know that 9 is not a set? Because it don't have the little set dudes on it, yes? So it could be an element. It could never be a freaking subset because it ain't even a set. Yes?
So to be a set, so A and B are sets, right?
Because they are collections of elements.
Yeah.
Yes.
Okay.
So I want this. Now look. Is everybody cool with that? So this one's true because they both have 4. This one cannot be true. This is false because 9 cannot be a subset because it's not even a set. So let me ask it this way. What if I wrote this? Okay, I'm going to change the question. What if I, instead of that, wrote 9 like this? Is that true? Could this be a subset? Yes, because it's a set. Now you have to actually do some work. What is A and B?
Wait.
Okay. So this had no chance. Yes? Because the only thing that could possibly work here is an element of, because 9 is not a set, so therefore it can't be a subset. So you can eliminate that shit without even thinking about it. Ain't no way this is true. Yes? It's like me saying, hey, you know your friend Tom, is he a horse? It's like, what? No, Tom's not a horse thing. So there's no way that could be a subset of this because that's not a set. So how could it be a subset? Okay, maybe.
I get that.
Now is it a set? How many things are in this set? How many things are in this set? One thing. So that is a set. It is a set that contains 9. So could this be true? Yes, that could be a subset.
Wait. Hold on.
Yeah, sure.
I thought that 9 was an 8. I'm not gonna lie. So how is that a 6? Just because you put those things over it. How can that be true?
Okay. Is 1 an element of A? Is 1 an element of A?
I'm so confused.
Is 1 an element of A?
Yeah.
Yes, because 1 is in A, yes?
Yeah.
Okay. This is the set that contains 1. Do you see that that's the number 1? And that is an element of A. That's in the set A. That is the set that contains the number 1.
Oh, okay.
This could be a subset of A. Yes? Is that true? This set is a subset of A because I can find this set in A. This number is an element of A because I can find that number in A. So when I draw those little squiggly lines, that changes everything. The thing I'm looking at now is a set. It happens to have one thing in it, but it's still a set. Okay. Now, so is that a set? Is this a set? Yes. It's a set that has a 9 in it, yes? So, does this symbol make sense then? Could this symbol be true without even looking at it? Could it be true? Yes. A set can be a subset of another set. A number can't be a subset of another set because it's not a set in the first place. Okay, maybe. Okay. So can I be a junior officer in something if I'm not even a member of that thing? No. So I can't, so if I'm just the number 1, I can't be a subset because I'm not even a set. So how could you be a subset? So is 9 a subset of A intersect B? What is A intersect B? What is A intersect B?
So like 8 and
Yep, what's in A and B?
9. Like 27.
Good. So is that a subset of that? Can you find this set in here?
Yeah.
Yeah, there you go. So the point of this question is, do you know what symbols even work here? That is not a set. It can't be a subset. If I put little squigglies around it, now it's a set. Now it actually could be a subset, and it is. So what about this one? Does that symbol work now?
Yeah.
I'm not even asking if that's a true statement or not, but the symbol makes sense. Now I can analyze and see if it works. And we know what A and B is. It's 927, right? So is 9 an element of A intersect B?
So it's true, right?
True, because 9's in there. Kick ass. 2 is false, because 9 ain't a set, so it didn't have a chance in the first place. The second 2, because I can count, is true. It had a chance to be true because it was an element of, and that's what 9 could do. A 9 could be an element of something. Okay, how we doing? Is that all right? So that's one big deal of the homework. There's that one problem that said list all the symbols that are possible. If I have a set, I would never use the little e dude. And if I have a number, I would only use the little e dude, or not e, right? Not an element of. Okay. So somebody else was about to ask something.
Yeah. So on question 6C, would B mean 12?
No.
No. Okay.
So real quick, just to point this out, have you guys noticed that I warned you about this? The book uses T for 10 and E for 11 in like base 12, which is so dumb. We could just always use A, B, C, right? What's the first 2-digit number that we have in our number system? 10. That's the first thing I have to take care of if I need to make it a single digit. So what will always be 10? A. So what's B then? 11. Cool. So just always, I'm never going to give you T and E for freaking 12 and 10 and 11 because ain't nobody besides the dumb book that does that. Book ain't generally dumb. In that respect, it is. I'm always going to use A, B, C, D because that's what the rest of the freaking world is. I don't know why they did that. Now, real quick, 6 and 7 are huge. A lot of people, it's really weird. They don't do the wrong thing at the wrong time in both situations. They just do the same thing for both. Do you understand 6 and 7 are completely opposite kinds of problems? What's different between 6 and 7?
I'm saying convert to base 10, and you're saying
Yes.
convert to base
Which
7.
one do they start off in a different base than ours?
Six.
Which problem, 6 or 7, do they start in a different base? 6. Yes? That means when I put like number 6A, I can write the places for 6 and I know exactly what goes in each place. Yes? That's when the places are filled when I already am in that base. I'm trying to make this easier for which algorithm to kind of use. So A, B, C for 6. Like in part B, I'm going to have 5 spots and I can do 1, 3, 9, blah, blah, right? And then it's multiplying that. 7, they're blank. Base 7 on 7A is blanks. So what's base 7 look like? Starts with what place? 1's place? 7's place? How do I know how far to go? What's the next one? You can use calculators, okay. 343. And the next one?
It's 2
Huh? No, not because there's 4 digits. These are in base what? 10. I might stop, but I don't know yet. What is 7 times 343? 2401. So do I use this place? Why not? Because this is smaller than that, yes? So this is when the places are blank, because I'm not in base 7 yet. What does 3 mean, 1s? What does 6 mean? 10s, right? I'm in base 10. So the base 7 places are not full. That's when things suck a little more, because I have to divide, subtract. Over here, for example, this one, 1, 2, 0, 2, 1, they are each in a place. I know exactly how far to go with my places, and then I can just combine that shit and make a number, yes? If it's already in a different base, the places are all full, how do I put that together now? 181. How would I put that back together to make a number? How do I put this together? How many 81s? 181 plus 227s plus no 9s, blah, 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 and then you bam. So it's awesome. Everything is awesome when I start off in a different base. Do you all agree that if I give you a mine number, it's easier to convert that to ours instead of the other way around? Of course it is, because it's multiply add. Do you guys see that? Number 6, it's already in a different base. The places are not empty. There's nothing for me to figure out. I can just put that shit together. If I'm not in the base yet, all the places are freaking empty. And I'm like, oh shit. So how many 343s? We gotta divide and see, right? And then you subtract and blah, 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 yes? You have to figure out what goes in each place. And that's when I tell you to go too far to make sure you went far enough. That's why we went to 2401, just to make sure we went far enough. Okay, maybe. Don't listen. When I explain something, If it still doesn't make sense, just say, hey man, I really still don't get it. That's okay, that's fine. I'm just trying to read some of your faces. Some of your faces could just be like, I'd much rather be somewhere else. I'm like, okay. As long as this makes sense, I'm okay with that.
Can we solve 8?
Which one?
Can we solve 7?
7A?
Yeah.
Do you agree with what I've done so far?
Yeah, so you did 1 times 7, and then 7,
7, 7, 7, 7. Okay, and then I went too far, and I always go too far, so you know that where you went is far enough. What's the first step, everybody? Yeah, how many 343s go into 1763? So I can see how much can this guy take care of and what's left for everybody else. So I'm weird, I just am. If you haven't picked up on that yet, I am. And I look at this like, I got this much work to do. How much can this guy do? What's left? How much can this guy do? What's left? That's kind of the way I have it in my head. So help me out. What is 1763 divided by 343? And I'm aware that sounds like a history question, but 5? Okay. Then, I showed you kind of a shortcut, I think, with you subtract below. But all you gotta do, what's 5 times 343 and subtract it, because how much work did this guy do? I got this much work to do. How much did he do? 5 times 343 is 1715? Yes. So then you do 1763 minus 1715. 48. You're okay. So then how many 49s do I need? He can't help me with thanks, 49. I can't do shit. You guys understand? We've done a lot of that. So you guys do know the process. You just sometimes do it at the wrong time. What's the only time I'm going to do what I'm doing right now is if I'm converting to a different base. Then these are blank. That's my entire work now, is to fill those places. Yes? Everybody with me so far? So I still have to take care of 48. How much can 7 do? 7 goes into 48 6 times, leaving me with 6. So 5066 base 7. Chabow! You don't have to put a little 10 if it's base 10, but you could. It's not wrong. I'm just gonna. But you better put little 7 down.
Well, we get more
Unless you do it everywhere, maybe I'll take it. It's not a crazy big mistake, but it's still not really true. If you don't put the little 7 down there. Is that okay? You want to try out part B now?
How'd you get the 0? Outside.
Oh, real quick.
All of last week.
Are you cool? 5 343s is 1715, right?
Yeah.
And then I subtracted to see how much we have 48 left.
Yeah.
So how many 49s are in 48? None.
0.
Yeah. So that's why I put a 0 here.
Um,
And then 6 7s takes care of 42, which leaves 6 for this guy.
Okay. So the 0 you got it because you can't play 48 and 49.
Exactly.
Okay.
So anytime the amount of work you have to do is bigger than what you're looking at, that's a 0. Move to the next two. Yeah? That feels a lot like general long division, the kind of stuff we do. So I don't know, do you guys want to try 7B right now, or do you want to do a different problem? It's up to you. Okay, go for it. Huh? 7B. If you haven't tried 7B out yet, try it. If you have, then okay, sit there and wait.
So 2, you want us to answer using a Venn diagram, right?
Yes.
Okay.
Well, that's kind of like showing your work, but on the test, I would definitely say constructive Venn diagram.
Okay.
Did I not say that?
No.
No, Jeff, you didn't. But without the Venn diagram, it would be really hard
Yeah.
just to know how to put things together. So let me catch up a little bit. What are my places here? 1s, 14s, 196, 270, 44. And the next one would definitely be way bigger than this, yes? Okay. That's the one time you don't have to go that extra place because you're almost already there with 2744. Has everybody got those same numbers down there for the places? Okay. So now you just divide, subtract, and divide, subtract, divide, subtract.
I got different numbers.
Oh, where? Did you get 196?
No.
Oh, so our places I'm going to catch up a little bit. So one of these, right? What the shit's that? I don't know. 365?
Yep.
Neato. And then I believe one of these. Is that good so far? I don't want to get ahead of anybody. I think that's 269, right? No, 160. Good job, Jeff. And then, is everybody with me on those numbers? What'd you guys get for this guy? 12, yeah. 169 divided by 14 is 12. 12 times 14 is 168. So you just got one for the little left over at the end. Now, real quick, you're not going to believe this. I will get this as an answer. Why is that obviously wrong? How many places did we figure out there should be? 4. How many places are there in this answer? 5. So this means 1 1, 2 14s, 1 196, 1 2744, and 1 14 times this. Holy shit, that makes a much bigger number, yes? What's the mistake somebody made? That has to exist in how many places? 1. So that's when we bring in the numbers. So what goes here? C. Now I've got 1, 2, 3, 4 places like I'm supposed to. Okay. Oh, thank God. Okay. I was worried about past Jeff. I thought I got that wrong. Is that okay? There's not a damn thing wrong with having the 12 there in your work, but then you have to represent it as a single digit, yes? Yes?
Could you go back, please?
Sure.
I'm so sorry.
You're alright. What's up?
For B, okay, so I know how to get all the way to 365, right?
Okay.
So you got there,
So one of these, right?
yeah,
And then you subtract and you have this much left, right?
yeah.
Okay. Now how many of these? What's 365 divided by 196? That's 1. I mean, it's kind of like you keep doing the same thing. What's 3109 divided by 2744? 1. Then you see what's left. So what's 365 divided by 196? 1. Then you see what's left. Are you with me?
Yeah.
You just gotta keep doing that.
So you got the one from 196, and then the 14.
Now, okay, so now if I do 196, I got 169 left. Yes? I had 365. One of these makes it 169 of that 365 is left. 365 minus 196 is 169. So that's how much we have left.
So you divide it and you subtract it?
Totally. Yes.
Like those two numbers, you divide it and subtract it.
Yes.
Right?
So. I need to put stuff here so that when I combine all of this, it ends up being 3109. So if I use one of these, I have to see what's left. 365. Then if I use one of these, I have to see what's left. 169. Then I could use 12 of these bad boys because that makes 168. So again, 365 divided by 196 is 1. Subtract 196, I get 169. What's 169 divided by 14? 12. And then 12 times 14 is 168, so then I have one left for the last dude. So if I take one of these, and one of these, and 12 of these, and one of these, I can make this. I'm trying to figure out how much of each thing do I need to make that number I've got. That's why I divide and subtract, because I see how much can this guy take care of, how much can this guy take care of, what's left for the next guy. We can do another example if you want to.
Can we?
If I said no, that would be so mean. All right, let me see. What if I want to make 511 and I want to make that in debate? What base do you want to go to?
15.
15, kick ass. I like it. Let me make this a little bigger than 3511. There we go. So where do I start for this problem? What do I do first? First thing I got to do.
You do one, like the placing.
Yeah.
One.
So I got ones,
You do 1 times 15, so 15.
15s.
And then 15 times 15.
Yep.
Let me do that real quick. Hold on. So 225.
Yeah.
And then 225 times 15.
Yep.
3,325.
And does it make sense the next one's going to be way bigger? I don't need the next one's going to be way bigger because I'm going to multiply by 15 again, right?
Mm-hmm.
Just always make sure you went far enough by making sure you actually go too far. What's the first step now?
The first step is to take 3511 and divide that by 3,000.
Yes! And in this case, I don't even have to divide, do I? I mean, how many 3375s are in 3511? Just one. Yeah. Okay, so how much of this number have we taken care of so far? 3375, right?
Mm-hmm.
How much is left for these guys to take care of? Right now I subtract. And instead of memorizing, just realize why it makes sense. Come back. Come back and stay this time. Please? Instead of memorizing the shit, one of these takes care of this much. So how much is left for these guys? So that's why I subtract. I don't have to memorize subtraction. I just have to know what the goal is. So of course I'm gonna subtract. I gotta see what's left. So how much is left?
136.
136, okay. So then how many 225s? Do I need any 225s?
No.
Nope. So then how many 15s? I made a good number on it.
This is the part where I get stuck.
You do the exact same thing. How much do I still have to take care of?
15.
No, that's the building
So you
blocks.
gotta take out.
I gotta take care of the 136, right? How much have we taken care of so far? One of these. What did that leave me with? This. Did this guy help me out? Nope.
No.
So I still got this much, yes?
So how many times 15?
Yes, totally, yes.
Nine?
9.
So you put 9 over 15, right?
9 over 15? And 9 times 15 is 35, I believe.
Oh, you do 9 times 15 then?
Yes, because now 9 15s took care of how much? 135. So how much is left? 1. Okay, so that'll be 1091 base 15. I didn't have to use any freaky ABC stuff just because I didn't need more than a single digit of each. Okay. So what else do you want to look at? Anybody? Word problems. Okay. I'm really interested. Did anyone try? Okay. Which one do you think is my favorite problem? No, actually no. The last one's boring as shit. But it's good. It's good. I'm not saying it's not good. I'm just saying it's boring. The train problem to me is so kick-ass. Did anyone try the train problem out? Or did you just look at it and go, well, at least I know he's not going to give me that one? I understand. I appreciate your honesty. Man, students are really honest this semester. I love it. So, did you guys look at the train problem? So, a 2-mile-long train moves at 60 miles an hour, and it reaches a 2-mile-long tunnel. So, tell me this: at some point, will the train be perfectly inside the tunnel? So what's going to happen for this entire train to pass through the tunnel? So it gets to the tunnel, right? Its little nose is right up to the tunnel. Yes? Then it goes in. So it's got to get all the way in, and then it's got to get all the way out. So this is a 2-stage problem. If you draw a picture, everything is easier. One other really important thing. 60 miles per hour. Do you think it's going to take hours for this train to get through the tunnel? So let me ask you this. This is the key that people don't notice. Do you see how it says how many minutes does it take? So I kind of gave that away. It's not going to take hours. It's going to take minutes. Yes? Or else something really weird happens in the tunnel. We're assuming it's going to continue going 60 miles an hour. Yes? If I'm going 60 miles per hour, how many miles per minute am I going? Well, how many minutes in an hour? 60. So we're going 60 miles per hour, which is also 60 miles per 60 minutes. 60 miles per 60 minutes. So how many miles per minute?
1 minute, 1 mile.
1 mile per minute. If you're going 60 miles an hour, you're going a mile per minute. How much do we ever think that way? Never, Jeff. Only with you, man. You're freaking dude. Okay. So 60 miles an hour is the exact same thing as 1 mile per minute. Just keep that in mind next time you're going 60. Yes? Or you're going, 80.
Wait, you said 6. Wait, what'd you say? Go back on.
60 miles per hour
Mm-hmm.
is the same thing as, and you're the one who told me, 1 mile per minute, right?
Mm-hmm.
So every minute this train goes 1 mile. Can you draw a picture where the train is just about to enter the tunnel? How great of a picture does it have? Not. Wait till you see my pictures. My train is a big rectangle with the word train on it, and my tunnel is a big rectangle with the word tunnel on it. You don't have to, do some crazy.
So is
You
it
could.
120?
Huh?
Is the answer 120?
No. No.
Wow.
How'd you get 120?
Wait, so 1 minute is 1 mile, right?
Yeah, it goes 1 mile per minute.
Oh wait, I'm tripping. Never mind. Couldn't say it.
So the 60's gone, right?
I
I know what you did, but it's okay. Is there any drawing a picture? You don't really have to if you don't want to, obviously. So I got my tunnel. And right in front of it, I got my train. Right at the edge, right? Train. This is how long? 2 miles. And this is how long? 2 miles. Not drawn to scale. Leave me alone. Can anyone see? Well, what's going to happen? Don't even draw this, but after 1 minute, what's going to be true? How far will the train have gone after 1 minute?
1 mile.
1 mile. Will the whole train be in the tunnel yet? How far will it be into the tunnel? Halfway. So how many minutes until it's entirely in the tunnel? 2 minutes. Can you redraw the picture after 2 minutes? What's true after 2 minutes? Two minutes later. So I've got my tunnel, and inside my tunnel is my, well, it should be like this, train. Do it better on the answer key, but oh well. Should be right at flat, right? 2 minutes later, the train is perfectly in that tunnel, yes, for that instant. Ain't no part of the back end, and it ain't coming out of the damn thing yet. It's perfectly in there because they're both 2 miles long. Okay. And if you ever got stopped by train, you know there's some trains that are 2 miles long. Has anybody ever stopped for a train like that before? All right, sorry. So how long until the damn train gets out of the tunnel, man? 2 more minutes, you're done. 4 minutes. After 4 minutes, that train. So drawing a picture is the key to this problem. The one little other thing, of course, was if I say minutes, and that's miles per hour, I got to change that to minutes to match the time that we're talking about. Anyone do anything like that? Most of you guys just say, that's cute, Jeff.
How can we do it different way? Like without
I don't know. That's the way that came to my mind, so I'm kind of stuck there. You know what I mean? You could do it algebraically, sort of, without drawing a picture and just realize it has to go 4 miles. So you could actually figure out it's got to go 4 miles. 2 miles get in, 2 miles get out. And if it's going a mile a minute, then it's going to take 4 minutes, right? You don't really need the picture, but the picture makes things a lot clearer. Okay. So if somebody solved this without the picture, I would need them to explain what they did. It would be okay. I didn't say to use draw a picture, but draw a picture makes a lot of sense here. What about the other word problems? Anybody else try those out?
Is the first one we're just converting 2,620 into base 9?
No. There's nothing about bases here.
Okay. Oh.
So Bill, the thing we know is he has 9 times as many peach trees as apple trees. Why? That's freaking Bill. He just does that shit. You guys, so we know that for sure. So if I tell you, I think he's got 260 apple trees. How do you verify that? Well, if he has 262 apple trees, how many peach trees does he have? 9 times that. And what do they have to add up to be if that's the correct thing? 2,620. So this problem, you don't even have to use a variable or anything. You just have to realize, oh, he's kind of asking me to check the answer. Somebody got 262, I just got to check it. So if I let apple trees be 262, 9 times as many peach, okay, 9 times 262, and if it's the right answer, they should add to be 2620. So that's like the last step in a word problem is you check your answer. So we just say it, check your answer. Or check their answer. Now if you did the algebra, a little tear would escape. You didn't have to, but I would go, it's so beautiful. But you don't have to, so. Okay. Is that okay? So you can either just do the algebra, so you could go apple trees is x, so peach trees is 9x, and then you can actually solve that equation and get 262. Or just plug this shit in. No algebra then, yes? Okay. Algebra kicks ass, but sometimes it's the dumbest way to do it. It just is the truth. So when you're in algebra class, we can't say such things. But when you get out of algebra class, we're like, sometimes it's the best way to do things, sometimes it's the worst way to do things. It's just another way to do things. What about number 10? That's very much algebra. Very, very much algebra. You could guess and check until you go crazy. But obviously I said use the variable strategy, so I'm kind of leaning in that direction. Did anyone try number 10? What's the one? We did 3 consecutive numbers on the sheet, remember that? This says 3 consecutive odd numbers, right? So somebody give me an odd number. 5, what's the next one? What's the next odd number after 5?
11.
7. It's okay. So 5, next odd number 7. What's the next one after that? What do you keep doing? Whatever you start at, how do you find the next one? You add 2. Yes? So, in this problem number 10, do you know what the smallest number is? No. So what are you going to call it? X. What's the next odd number? Right, so the smallest odd number in this problem is X. Could you have called it Y? Shit, yeah. Could you have called it S? I wouldn't, because my S's look like 5s. What is the middle number? What's the next one? What's the next odd number from that? X plus 2. And what's the last one? The largest one? Yes. Is that cool? 5 plus 2 is 7, 5 plus 4 is 9, 5, 7, 9 are consecutive odd numbers, yes? Now what's supposed to happen? What does this thing say happens? When you do this to this, you get this. When you take the, you got 3 numbers there, right? What's supposed to happen? Which one do I not give a shit about? What's supposed to happen? The sum of the, so if I take the largest and I add it to, no, twice the smallest. So what would that look like? The largest is x plus 4 plus 2x, because twice the smallest is 2x. So if I take the largest and I add twice the smallest, I get 67. Don't get got. And then you solve the damn thing, right? Solve it. Subtract 4, add x and 2x, divided by 3, blah, blah, blah. You guys see how to solve? You guys cool with solving that one? Okay. Now what you get is not the answer. Because I am the answer. So students are so used to just stopping when they get x, but why is that not the answer?
Because I plug it into the x plus 2 and x plus 4.
Yeah, so 21's not the answer. What do I want? Specifically, what do I want? Middle number. So what's the middle number then? Yeah, what's x? 21. So what's the middle number? 23. So when I teach word problems, I tell people identify the players, give them all algebra names, write down how they relate to each other, solve, and then you can go back and answer any damn question I ask you, because you've got the algebra names for all the parts. So those are the word problem ones. Just remind you guys, I have the answer key for this, right? Maybe I'll give it to you. Do you want the answer key right now? Okay. It's written by hand, so I'm sorry. I think I wrote it really well. Oh, that'll do. Oh, that's your emotional support group. I've had several people with emotional support. That's you over there? Okay, the whole other person. Everybody got an answer key? Did I miss anybody?
It's a
Okay. So, alright, so this is your very first practice test from me. This is your very first answer key. If you did not try the practice test, don't look at this. You're gonna do this. Yeah. That's what I would have done. And you're gonna build all this false confidence because it's so easy as shit to agree with somebody else doing work, right? Don't look at this if you didn't try the practice test. Trust me. You understand? I can't control you. If you want to look at it, you can. But you're going to build false confidence because it's easy to agree with me. Yes? Okay. Also, I keep forgetting to say this. The practice test problems, you should only try them maybe twice. And if it still isn't coming right, go find a different problem. Because what I have people do is they'll try the practice test like 7 times. Then you know those problems. You don't know how to do a different problem. You understand? I've had the very first time I taught, somebody said, I took 7 hours, Mr. Wallers, just doing your practice test over and over, and I still got a D on it. I'm like, yeah, of course, dude. I'm not going to give you these problems. You have to know how to do those kind of problems, not those problems. In fact, let me say something I don't know if I've said. Any problem on this practice test doesn't mean shit. They are all don't mean shit. What's important is, what do I do in this situation? Because I'm not going to give you any of these problems, but I am going to give you problems like this, right? I'm not going to give you convert this number. I'm going to give you convert 7,000 and whatever, different number. Here's I'm averaging about a 97 on my answer key. So if you see something that looks like it might be wrong, it could be, because I'm just a human doing my best. Yes.
For A, like the second one. So
2A.
yeah, not A and B.
Oh, here.
Yeah, at the top. So you know how like there's not an A is 0, -5.
All right, so let me write this up. So not A, you figured out is 0.
0, -5, and then -8.
Okay.
So would the and be like what's in B or like?
Yeah, the and. So this literally means what elements are in this set and this set. So what is in not A and in B? Which things are in both?
-5 and -8.
There you go. Hopefully that's what I said. That's what I said. Yeah, good job. Does it make sense? And literally means only write the things that are in one set and in the other set.
And then the third one means what's not in A or B?
So you figure out what A or B is first,
Yeah, and
then you knot it. Yes.
not it.
Could you go over the Venn diagram? I don't understand.
Oh yeah, good, because it's really hard on an answer key for me to show how I put it together. Can you guys tell me what is the number to start with in this whole big paragraph of shit? What number do I start with? What's the most important thing?
19.
No. Well, first off, let's draw a picture. How many circles do I need? How many circles do I need? 3, because I have, what is it? History, chemistry, statistics. And you don't have to have H, you could have these in different arrangement, right? I just put it as they came in the problem. Do you guys remember where's the most important place to start? The middle. Because we know for sure how many are taking all 3. 2 are taking all 3. Now watch, I really want you guys to understand what I'm about to do. And you're like, you're gonna write a 2 down. Yeah, it's not, but The second I write a 2 down, how many history students have I accounted for? 2. How many chemistry students have I accounted for? How many statistics students have I accounted for? They just happen to be students that are in all 3. But don't have 2 in every class now. They happen to be the same people. Who gives a shit? So now when I take a step out, I go from the inside out. What's the first and? 2 students study all 3. 8 study history and statistics. How many are already in history and statistics? So how many more do I need? And where does that 6 go? That's very hard. Go, do like this. It goes right there, Jeff. 6, right? How many are in history and statistics now then? 8, yes? Because all the ands are these little ellipses there, yes? And do you see now how to just keep going? You just kind of spiral out. You're like, yes, dude, that's what I'm doing. I'm spiraling. I'm sorry. So 3 study, I'm sorry, I missed those. 8 study there. 3 study history and chemistry. So what am I missing between history and chemistry? If 3 study history and chemistry, how many do I have so far? 2. So what goes here? 1 in the little like enterprise insignia there. 1. Do you guys see that? From the inside out. Because the inside is the ultimate overlap. If you go from the outside in, you're going to create people, which is neat. We have that capacity, just not that quickly. People. Is that okay? Can you now kind of do it and then check against the key? Okay. Let me know if you have any issues. You never know with past Jeff. Was he drinking booze? Was he insane at the time? He could be right now. So I do make mistakes. Oh, shoot, I forgot. Here. Before I forget, guys, I'm sorry. I have some graded stuff. Aaron? Sophia? Shalem? Okay. Drew? Grace? Jalen? Bum, bum, bum. Bum, 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 bum. Yes?
How'd you get the 10, 9, and 11?
Oh, okay. So here, let's keep going. 21. Oh, I'm sorry. I'm not there yet. 3, and then you have 4 study stats in chemistry. So I've got 2 already, so I'll put 2 there. That completes the little inner things. Now, 19 are studying history. How many are already in the history circle? 9. So how many more? 10 to make 19. And then you keep going. That's why you start in the innermost, because that already puts some in every circle. So you're not like creating people. You're double, triple counting people.
2 and then 1, and then out of the.
Yeah, so like chemistry, you've already got 5 people in there, yes? And then you just gotta see how many total and see how many more you need to put. Yeah, good. What goes on the very outside of the 3 circles, but inside the box? 2, because 2 don't study any, so they're outside the circles, but they're in the universe. Yes.
Can you do 3A and B?
Yes. What do you think is the first thing to do in 3A? Algebra must have whipped this into you, right? How do you evaluate a question like this? What do you do first? How would you do 4 plus 5 minus 7, or I don't know. What do you do in here first?
We do the parentheses.
Yes, good. So what is B or C? What regions are B or C? We're going to do this a little loose.
So 4, 7, and 3.
Huh? No. What regions are in B or C? Oh, I see what you did. So tell me, what regions are in B? Let me get a clean
6,
one.
7, 3.
Do I have a clean one? Yes, I do. Yeah, so 2, 6, 7, 3 are in B. What's in C? 4, 5, 6, 7. So what is in B or C? Could be in either one. Which regions are either in B or in C? What regions are either in B or C?
So did you just put those numbers together? Or?
Yep, 2, 6, 7, 3, 4, 5, right? Now, I want everything that is in A and this region. So what is in A and this region? Yeah, 2, 5, 6. So the answer to this question has to be in A, and it has to be in this. So is 1 in A and in this?
No.
No. Is 2 in A and this?
No.
Is 2 in A?
Yeah.
Is 2 in this?
Oh, so it's not just like B and C, it's B or C.
It's B or C, yes.
Yeah. Okay.
So 2 is part of the answer. I don't need a set, Jeff. 5 is part of the answer, and 6 is part of the answer. Because those are the 3 that are in here, and they're in A. Now part B, now you see the difference, because otherwise part A and B look the same, right? But in part B, why is it different? I don't expect maybe the answer is going to be different, because now I do the and first. So what is in A and in B? What regions are in both the A and the B circles?
6 and 2.
Okay, 2 and 6. So I want 2 and 6, or the stuff in C. So one way to look at or is you start with the first two. It's got all that shit. Or this other, then you just add in all the new stuff from the other set. Yes?
I thought you said I didn't mean because it's like a
Yes, you combine everything together. This is why it makes the answer bigger. So I'm definitely going to have 2 and 6 in my answer, because that's in this. Now what's in C that I haven't listed yet? Because it could be or C. So what's in C I haven't listed yet? What?
So 4, 5, 7.
4, 5, 7. Yep. Cool. Did Past Jeff do that one right? Past Jeff, does he know anything? Yes. Good job, Jeff. So it's exactly like algebra, where you do in the parentheses first. You got to figure it out first. All right, you guys. We've done so many of these, like number 4. You guys feel okay about number 4? I'm gonna give you exactly the same thing I gave you for the quiz: the Mayan place value system, the Egyptian symbols, and the Roman symbols. You have to know Mayan symbols, Babylonian symbols. Babylonian base. What's the Babylonian base? What's the Babylonian base? 60. I give you the Mayan base because they're a little bit weird.
So you want to give us like the symbols and the bases on the test, right?
I'll give you everything I gave you before, which was the Mayan places and the Roman symbols and the Egyptian symbols.
Okay. Yeah, because I didn't see it on this test.
Oh, no, yeah, because I already gave it to you on the quiz room, the
Gotcha.
handout and all that stuff.
That makes sense.
On the actual test I'll have it,
Okay.
because then you can't access anything. Yeah. If you haven't turned in quiz corrections yet, what do they do? Thursday. Can you turn them in after that? Yes, you can. Can you give me quiz 1 corrections on the day of the final? Now, one way to answer that is like, yeah, but then you're not going to do anything with it. Yes, I will. If you get enough of the corrections right, you might get a point back or 2 or whatever, depending on how many points you missed the first week. It's very good. The later it is, the less points you could get back. You'll never get below what you got. You with me? Even if you turn corrections in and there's something I forgot to take points off for, I'm not going to do that. That would be so evil. Nobody would give me quiz corrections then, yeah? You're like, I don't know if this guy missed something. Screw him. No. You with me? Yeah. So anything else? Homework stuff, quiz stuff, practice test stuff. We've done pretty good. I think we hit almost all the ideas. What have we not looked at yet? We didn't really do this, but again, we should be at a point where this is good, maybe? I still see people doing this mistake. They'll tell me this is 23:31. There you go, Jeff. What mistake did that person make? What mistake did this person make? Well, first off, do you see where you got the numbers? Right? Because that's 23, that's 31, but this is what place? What place is this in? Ones, yes. And what place is this in? 60. So I have 23 60s and 31. I got to put that together, right? What's the only system where you can just directly translate the symbols and be done? The Egyptian. I know you're pointing at the Egyptian. No. Look over there, that tree. It's right there, Jeff. The answer's right there. Roman is almost good. What's the one thing about Roman? What's the very first thing you should do in a problem like part D there? Very first thing you should look for here. Sorry, here. Yes. So where do I have a pair where the one in front is smaller? So like C is smaller than M, that's going to be what operation? Subtraction. X is smaller than C, I is smaller than V, blah, blah, blah. Yes? Very first thing you do is find those. So then you subtract instead of add for those, yes? And then at the end you just add it all up together. What does the IV with a bar over it mean? You're like, is that a weird bar that's in a hospital? What's the bar over top mean? Times 1,000. Yeah, the IV bar. Intravenous bar. No. So that would be 4,000, blah, 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 whatever the rest of it is, yes. What is the wrong way to write 4,000? That seems right, but it's wrong. M, right? Why is that wrong? More than 300. Why is the rule that? I don't know, go freaking ask the Romans. I don't know why they did that shit. It kind of makes sense, because what's wrong with the Egyptians? If I wanted to write 9,999,000, that would so suck. So the Romans are like, oh, look at those Egyptians, let's not do that shit, okay? No more than 3, alright guys? You see what I mean? That's one reason why they did it. Okay. Yeah, I think we talked about every idea. That's pretty good. I think this is the only one that I think maybe you have a question on, but it's up to you guys. And just to let you know, if you are ready for the test, you do not have to stay. Somebody was excited when I finished saying that. That's always true. Now, if you have questions, ask for it. just printed it out?
I can have the phone.
Huh?
Yeah, it's
It's
this
here.
one right here, yeah.
Yeah.
I just need to change something right
Yeah. Yes.
A question about your work.
Okay.
One of the first, one,
Wait, I'm sorry, which one?
sorry. 1A2.
Oh yeah, I got you.
I also have. Wait, okay.
Thank you.
Are you?
Sure.
How do you have 0, but not in the actual? You might have 0, -5, and 8.
Yeah.
But like when you box it, there's no 0.
Oh, so not A is 0, -5, -8. Is that cool? Is that okay?
Yes.
Now what's the question asking me to calculate? Not A and B. So what things are in not A and in B?
Oh, it has to be this.
They have to be in both.
Oh, okay.
B doesn't have a 0, but it does have -5 and -8.
I see.
Okay. So I constructed not A because I didn't have it, but B is right there. Yeah.
So it has to be.
So the first part is just what set am I missing to even do the problem, and then the box one is the answer.
Got it.
Somebody's looking like, is he really gonna be okay if I? Yeah. Yeah. Five. Five B?
D.
G, okay.
Yeah. What is 40?
Let's see, five G here. Which part? Oh, no. C is smaller than M, yes? Yes, so this is 4,900. X is smaller than C, yes? 50 minus 10. 40. Oh, that's 90. Minus 10 is 9. What did I put? Did I put 4?
Yeah.
Oh, Jeff. So guys, if you're still here, why did I do that? I just did it again, so it's in my own head. Right here, guys. If you're still here, alright, if you're interested, I made a mistake on the answer key. Let's see if anybody knows. So the mistake I made on the answer key was, there should be 100 minus 10. There should be a 90. There should be a 90, so it should be 4990. Thank you. Law of averages said I had to make a mistake somewhere. Okay.
Can I turn my homework in?
Yes. Thank you.
You can go. So on Thursday, I'm not gonna be here because it's my birthday and I have a skydiving,
Dude.
like it's already booked.
Okay.
And
Do me a favor, send me an email. I'll tell you when my next tests are happening, because that would be the easiest time to do a makeup test, is if you could come to another class that has a test.
Okay.
Does that make sense?
And then also, I just got the book, so I haven't, like, you're not gonna see any homework from me for right now.
Now you remember that I posted scans of the first few homeworks in Canvas, so you could have been doing those homeworks.
But, okay.
I showed you guys. I
I'll go do it. I'll get on it today.
So you got the books, you can do it. Okay.
I'll bring it on Wednesday.
The most
Are you
important
here
thing
on
is to
Wednesday?
do enough practice,
Okay.
right? That's the most important thing.
Are you here on Wednesday?
Yeah.
Okay. So tomorrow, I can bring in my homework tomorrow, just to get.
No, you don't have to give, unless you want to, but.
Well, I want to pass this class.
No. If you give it to me Wednesday, or if you give it to me the day you take the test, it's going to count the same.
Oh, so it's not gonna be late.
No.
Okay. All right.
So it's due the day you take the test.
Okay.
Yeah.
Sorry, I wasn't here the whole last week because I was so sick. Like I don't know what happened, so I didn't come in at all.
I got you.
But I'll be there.
And you remember I do record the lectures.
Yeah. Do you post
Currently
on
recording, so that's the exciting part.
Campus?